All right, we're going to be on page 170 if you want to open to it. Oh. More? Oh. Hey, I'm all right. How are you? Yeah. Is it possible for me to call you back in about a half hour? I'm just online with some students and a teacher in Raleigh. So could I call you back in half hours? Okay, can I take your number then? Sorry about that, Logan. I'm just getting on the air live here. Okay, so it's yeah. 929 2637. Okay. 9805. So 2019805. Perfect. Okay. Probably in about a half hour or so, if that's okay. Awesome. I appreciate it. Thank you. Okay, bye. All right, I'm just going to get started. Sorry, I had a phone call there. All right, so what we're looking at in 8.1, this is a pretty important section for us because we're going to look at it in grade 11 again, and we do systems of equations of inequalities in grade 11. So we want to get this one down pat. So basically, all that we're going to do is we're going to take two equations. So the last section, all we did was graph one equation. Now we're going to graph two equations, and we're going to find out where those two equations meet up, and if they do meet up or don't meet up. And what we learned in the last section is if two lines are parallel, morning Emma, if two lines are parallel, then they won't meet up. So what I'm going to do is I'm going to look at the example they have in here. And there are three ways in which we look at solving systems of equations. And the first way is just to graph them. So I'm going to take a look at their example here. It says, consider the system of linear equations. Y equals 3x plus 2. So here's equation number 1. And equation number 2 is 2x minus y equals 4. So this is on page 170, girls. And actually, if you don't mind, just put your computers on mute just for now. And if you have something to add in, then just unmute it, okay? Perfect. All right. So the first thing that we're going to do is we are going to look at graphing both of these. Now, I'll graph them on the board poorly, and then I'll graph them using technology so that you can see it. Oh, actually, I have this wrong. This should be a -4 here. Okay? So to graph y equals 3x plus 2, it's already in y equals mx plus b form. So I go to 0 and 2. And then I go up 3 and right 1 to right there. And draw my line. So again, my y-intercept is 2. That's this guy. And my slope is 3/1 for this graph. The second graph on this equation, it isn't in y equals mx plus b form, so I'm going to change it into it. So I'm going to go minus y equals minus 2x subtract 4. and then y is equal to 2x add 4. So I have subtracted the 2x to this side, but it left me with a negative y right there. So I don't want a negative y. All right, I want to have a y equals. So now my y-intercept for this guy is 0 and 4, and my slope is 2 over 1. Okay, so I'm going to go to 0 and 4 right here. Then I have to go up 2 and then over 1 to right here. And I graph it, and because I've drawn it so poorly, I can't see a connection point. So what I'm going to do then is I'm going to go back over to here. I'm going to graph the first one, which was y equals 3x plus 2. So I have it there. And then I'm going to graph my second one, which was 2x minus y equals negative 4. And what I'm seeing is an intersection point right there. That intersection point looks like 2 and 8. Okay, so the first thing that we are doing is we are just attempting to graph two equations and find out where they intersect. So that intersection point was up here. That coordinate was 2 and 8. Now there's something that's important to take from that, because I can now check to make sure that I've got this right. So what I'm going to do is I'm going to look at each individual equation. I'm going to substitute in the coordinate 2 and 8 and check that it equals on both sides. So equation number 1 was y equals 3x plus 2. I put 8 in for y and 2 in for x. So I get 8 equals 3 times 2 plus 2. 8 equals 8. So I know it works for the black line. 2 and 8 is definitely on the black line. So let's check this guy. 2. Oops. I've got 2x. Oh, I did it again. 2x minus y equals negative 4. So 2 times 2 subtract 8 should equal negative 4. So I go 4 subtract 8. That's negative 4 equals negative 4. It works. So I can tell that 2 and 8 are on both of those lines. And if you look on page 171, it gives you the same graph that I just gave you. Now, because we don't have the technology to do it necessarily yet, although we do, and maybe we get into Desmos already, that might not be a terrible idea. For right now, you're going to graph these yourself. You need to have graph paper in order for these to work out properly. So I just want you to somehow see if you can get some graph paper. If you don't have graph paper, email me and I can set some out for you. But for right now, that's what we're going to do. Okay, so let's have a look at question 1 on page 171. And again, in chapter 7, I showed you 3 methods in order to graph. The first method was to change it to y equals mx plus b. The second method was to use your x and y intercepts. And your third method was just to do a table of values. I'm okay with any of them. Myself, I prefer y equals mx plus b, unless, of course, my y-intercept ends up being a fraction. But anyways, we'll just go through and see how this works. Okay, so it says rewrite the equations in slope-intercept form, then use technology to graph each pair of equations and determine the point of intersection. Okay, well, let's write them in slope-intercept form. So I lost you for a second there. Sorry, girls. Okay, so I've got x plus y equals 6. So to rewrite that in slope-intercept form, I have to get the y by itself. So I need to get rid of the x. So to get rid of the x, I subtract it to this side. So y equals negative x plus 6. 2x subtract y. 3y equals 2. All right. So now I'm going to go 2x. So I'm going to go negative 3y is equal to negative 2x. Add 2. I again subtract the 2x to the other side. And then I'm going to divide by 3. So that's 2/3 x plus, that'll be a subtract because I have to change the sign, negative 2/3. So the y-intercept for this guy, y-intercept is 6, and the slope is negative 1/1. The y-intercept here is negative 2/3, and the slope is 2/3. So I could graph both of those. Now, at this point right now, I'm going to make a suggestion to you. In grade 11, we use an app that is free that is called Desmos. And this is probably the best app that I've found so far that helps you graph. And it's something you can get on the iPhone, you can get it on an Android, you can get it on your laptop. It's a free app. I would suggest getting this to help you graph these equations. Okay, so just food for thought. So if I go back to this, I would have to go to 0 and 6, and I go down 1, right 1. Over here, I go to 2/3, and then I go down 2 and right 3 of that point there. Not that easy to graph. So what I'm going to do is I'm going to use technology again to graph it and find out where those two graphs intersect. So I go So looking at my equation, I have x plus y equals 6. So there's equation number 1. So I go to 0 and 6, I go down 1, right 1, takes me to this coordinate here, and now I've got my line. That equation is set up nicely for your intercepts as well. If I put 0 in for x, I see y is equal to 6. If I put 0 in for y, I see x is equal to 6. So the second way in which I would maybe graph these guys is put 0 in for x, solve for y, put 0 in for y and solve for x, and I would get those two coordinates. So those two coordinates are 0 and 6 and 6 and 0. So that is one other way in which we can graph them. I'm now going to graph the second of the equations. Okay, graph it. And I have an intersection point. My intersection point is right here, which is at 4 and 2. Trying to get it right on both, but I can't seem to. Okay, so 4 and 2 is my intersection point for these two graphs. All right, and again, I can check my answers at all times. I can check my answers by graphing them, and I can check my answers by substituting into the graph for them. All right, so what you're basically doing, girls, is you are basically just doing graphing two lines and finding out where they intersect. That's all that is basically required of you in that first section. We just want to find out, how do we solve they say linear equations and graphs, finding out where they intersect, where the two lines cross at. Okay, if you look at number 2, it says determine whether or not each point is a solution for the graph. Well, you could graph it and you could find out where they intersect, or you could plug in X and Y and make sure that the left side equals the right side. One of the things that we tend to forget, if I look at number 2, so equation number 1 and 2 is y equals 4x minus 9. Because it's an equation and x and y represent all of the coordinates on that line, when I substitute in, my left side should equal my right side at all times. So they give you 2 and -1 as the coordinate. So I substitute that in for y, this in for x, and they have to equal each other. If they don't equal each other, then we know that the coordinate is not on that line. So I get -1 is equal to 8 subtract 9, -1 equals -1. So I know it works for the first equation. I would then check the second equation. Is that the right equation? Yeah. All right. Substitute in 2 and -1. So 1, -1, -2 times 2, add 3. And I get -1 equals -1. So in 2a, I know that 2 and 1 is a part of those equations because it works for both of them. All right. Okay. Just making sure I've got everything covered here. Any questions, ladies?
Could you do 5B on page 159?
Sure. Okay. All right. Okay, so the one thing I don't want to have when it comes to general form is I don't want fractions. So I need to get rid of the -3 and 2 from the bottom of the fraction. So what I like to do is I like to multiply it by the common denominator. Okay, so the common denominator between 3 and 2 is 6. So I'm going to multiply everything by 6. Okay, so now when I look at it, 6 divided by -3 is -2. So that leaves me with -2x here. 6 divided by 2 leaves me with 3 equals 6. So now that I've got the fractions gone, all right, all I need to do now is get that 6 to the same side as the x and the y. So I subtract it. And there's your solution. Can you see that okay, Emma?
Yep.
All right, does that make sense?
Yeah.
Okay, perfect. All right, was there any other questions this morning, ladies?
No.
We're all okay? Excellent. Okay, so what I would like you to do then right now is work on 8.1. I'm going to leave and the team meeting open for another half an hour or so that if you have questions, you can ask. So if you're working on it right now, you can ask questions when you need to. Okay, so work on 8.1. I'm just going to mute myself, and then I'll be in the room here waiting if you have any questions. Okay? Okay. Just going to mute now.